Hello and welcome back to my YouTube channel again. So in the last videos we have covered all the different type of regression algorithms in machine learning. So in the next upcoming videos we will similarly cover all the classifications related algorithm in machine learning. So before directly jumping to that, I will let you know guys, so where is all the notebooks that I have stored. So you can go directly to my profile. I'll put this link in the description also. I have a repo called Classification with Ravi, so you can get all the notebooks there. And if just for information, so I also been a part of Kaggle from last 1 year. So if you want to be a part of my journey, you can follow me there. And I'm a local rank 336 in notebook, and in discussion I am local rank. It's not a local rank, it's worldwide rank. So I'm 336 rank in notebook and 432 rank in discussion. So yeah, that's a additional information. So coming back to this first classification algorithm, that is logistic regression. So what is logistic regression? So as we have covered in linear regression, what it does is try to fit all the point using a single line. So just the difference here is logistic regression is just a linear regression with a sigmoidal function. So sigmoidal function is nothing but the mathematical expression. And what is the basic difference between classification and regression is classification problem directly try to divide a problem into some sectors like 1, 0, binary. If I have a 3 category also, and I have to predict which category it falls into. So it's a classification problem. But if I have to find a particular value, so it comes under regression problem, like predicting the price of a house. So yeah, let's move and first clear out all kernel output so that we can be on the same page. I won't go too much into detail because I just want you guys to learn more about it in theory part. So we will import all the necessary library that we needed, and we will try to check how much accurate our model is coming. So for this there is a CSV called social network ads.csv, and I have put it here also. You can take this and apply in your local local also. So just I'm reading this file. It contains 400 data points with some user ID, gender, age, salary, and that guy is going to purchase it or not. So yeah, we will just move ahead with try to see the class imbalance thing. So we are just checking 0 means not purchased, 1 means purchased. So we can see most of the people have not purchased and most of them has purchased. So yeah, we can see 237 and 143, but we won't focus too much of class imbalance thing. That we can cover on some different part, because if we go and talk about it, it will be very huge video. So yeah, we can talk it about in the next video, So the first thing, we check the null values. Yeah, we see we have no null values in our data set. The next thing we do is split the train and test split. So what we do is first we try to take only 2 parameters. First is age and estimated salary. So we are not going to take whether a male or female is going to buy it, but the most relevant features like age, what the age criteria and what the estimated salary is there, that person is going to purchase it not. So the x variable will be our feature as age and estimated salary, and our predictor y value will be purchase. So yeah, then let's see what are the shapes of data. So yeah, as I have said you, 400 data points. Let's split 1 by 4 means 25% of the data goes into test and 75% into training. So yeah, the first thing we do is we standardize it. So what we do here is we transform the xtrain. So xtrain is nothing but our training data set. We do fit and transform and put into xtrain, and for the test data also we xtest, we transform it. We just there is one thing also, just always remember that whenever there is a train and test data, we do fit transform. We wanted to fit that data to the model, and we want to transform the data only with the train data set. We never do fit with the test data. So we only just do transform, because this is the data we want to put in to our model to test how it's well performing. So yeah, just quick idea, just a suggestion for you guys, just to remember. So what we are doing, just creating a basic classifier here with a random set. Always define random set, because if you won't, every time you run the model you will get different accuracy and like precision, everything. So to fix your metric, always use random state. We just try to fit our x train and y train, and we try to predict the x test value. So yeah, our classification model is now ready. Let's visualize the training data set. So this is the data set we see. This is the line, it's dividing the two different part. The red is not bought, 0, and 1 is, but still you can see some of the like red dots, like 1 2 3 4 5, more than like 10 11 points are there, which is coming on the right side. It means like even though they are not purchasing, but they are coming inside this criteria. So this is the one thing we have to take care of. And if we have to check how our test data is performing, the other 25%, so yeah, let's see that also. So we see it's quite well, because only one data is getting predicted, is not purchased, even though our algo is telling that it's purchased. And some of the other cases like 1 2 3 4 5 6 7 8, this borderline also, so some of them are telling it purchased but it didn't purchase. So yes, accuracy is not too much. So if you don't know about accuracy, what I was talking about, so there is something called metrics. So there are different metrics to like check how well your model is performing. So one thing that we usually use is accuracy, precision, recall, and F1 score. So what I have written, true, positive, true, negative. So there is a dedicated video of this, like what's confusion metrics and what is this TPTN and everything. So you can go and watch that video also, because if I go explain in very detail, it will be very huge video. Just like to give a very quick context, I can tell you something like, because I have drawn a confusion metric. So this is actual and this is predicted. It means actually this is actual and this is predicted, mean if I am telling that people is not buying, and our model is also telling that people is not buying, so it's like I am telling that people are not buying, it means negative, and the model is telling that okay, you are correct, means true negative. This is true negative. Got me right? So yeah, that's like this. You can learn more about it. So, and let's see what are the different measures here. So we see all the like 89% accuracy, precision is 88%, recall is 75%, and F1 score, if you have never heard about it, is the combinations of the different accuracy and precision. So F1 score is the weighted average of precision and recall. Therefore this score takes both the false positive and false negative into account. So yeah, it uses both the recall and precision in the formula. So just we are dumping all this into a data frame so that it look nice. So model name, accuracy, precision, F1 score. Yeah, that's all about this logistic regression. So in the next video we're gonna cover more about KNN and the other ones. So yeah, stay tuned, and thank you for your time. Have a nice day. Bye.